Alright, we're going to do one that's a little bit more difficult. I do want you to notice that in this particular problem, we have some really big numbers we're dealing with. I want you to notice that we have 18 and we have negative 30. If I were to multiply that out, that's going to give me a very large number. So I should be thinking, is there a way that I can factor something out and make it smaller and more manageable numbers? So let's take a look. I want you to think about what number could we take out of 18, 21, and 30. So what number do they all have in common? Now looking at it right away, I know, well, 3 can go into 30, 3 can go into 21, and 3 can go into 18. So I'm going to divide out a 3 on every one of these terms, and then I'm going to place it outside of my parenthesis. Where later on, if we wanted to convert it back, we just have to distribute that 3 to all the terms inside. So 3 will go into 18k squared, and it'll go into there 6 times, so we got 6k squared. 3 will go into 21, plus 7 times, so we got plus 7k, and 3 will go into negative 30, negative 10 times. Now this is more manageable. So now that we've got it here, we want to go ahead and use that trick that we learned earlier in the previous video. We want to take our leading coefficient, our leading terms coefficient, and we want to multiply that to, I'm going to draw a line over here, to our constant. Now we're just going to deal with what's inside of the parentheses right now, because we're still trying to go ahead and factor this out completely, and we're just working on this particular part. So 6 times 10 is going to give me a negative 60. I'm going to bring down my 7k. I'm going to bring down my k squared. And I'm going to bring down my 3. So now that we've gotten to this point, what we want to do is we want to look at our factors of 60. So notice I'm not writing out the steps at this point because we already went over the steps. I'm just going to do the work. So my factors of 60, I could have 1 times 60, 2 times 30, 4 times 15. I could have 5 times 12, and I could have 6 times 10. Now what I want you to think about is we need two numbers that we can combine together, or two numbers that can be multiplied together to give me negative 60, and that can be combined together to give me a positive 7. So if we look at the first one, 1 and 60, well, if I combined 1 and 60, if one was a negative and one was a positive, I'd end up with 59. And if they were both positive, I can end up with 61. So that's not a possibility. 2 and 30, well, 2 plus 30 is 32. And 2 from 30 gives me 28. So it can't be 2 and 30. 4 and 15, that'll give me 19, and it'll give me 11. So it can't be that. Now, if I add 5 to 12, it gives me 17. But if I subtract 5 from 12, it gives me 7. So as soon as I know that, I should say, okay, I'm going to stop here. This is definitely going to be my factors, 5 and 12. So I'm going to go ahead and move this over to the side. And we're going to rewrite it with our factors. So instead of writing all this, we're going to go ahead and put our 3, because I don't want to forget it. And then I'm going to have my k, and I'm going to have this 5 right here. And I'm going to have another k, and I'm going to have this 12. Now I do want you to notice, looking at this, that at this point, I have not put my signs in here. I personally do not like to put the signs in the middle until I get everything worked out on a problem like this, so that I can see exactly, I better put some big parentheses around here, so I can see exactly which one needs to be positive and which one needs to be negative, so I can get my positive 7k. So at this point, looking at it, you may have already recognized, okay, well, you know what, it looks like the 12 needs to be positive and the 5 needs to be negative, because negative 5 from positive 12 will give me a positive 7. So I agree with that. I'm going to go ahead and place those in. So let's try that. We'll say that's going to be a minus 5. This is going to be a plus 12. And now we still have another step to do. Remember that we have to take that leading coefficient and we need to divide it out of both of these integers. So let's go ahead and do that. So I'm going to divide this by 6. I'm going to divide this by 6. So I'm going to go ahead and rewrite this. I have 3. And then I have k to the And I'm going to put minus 5. And remember, we have to take this 6 and put it up in front of the k. So I'm going to write my 6 in right there. So we got 6k minus 5. And then I'm going to go ahead and do this one, which is k. And 12 divided by 6, that's going to give me a positive 2. And there we go. Now, I kept this inside of the parentheses. I really don't have to do that at this point. This is the product, right? Anytime that we think about product, we're just multiplying it out. It doesn't matter the order. So I'm going to rewrite it as 3 times 6k minus 5 times k plus 2. Now, if you wanted to check your answer right, if you said, you know what, I think this is the answer, but I'm not absolutely positive it is the answer, we could double check it. We could go ahead and multiply this out. For instance, I could say, okay, well, 6k times k would give me 6k squared. 6k times 2 would give me 12k. Negative 5 times k would give me negative 5k. And negative 5 times 2 would give me a negative 10. So if I combine my like terms right here, 12k minus 5k is going to give me 7k. And it's going to be positive. Bring down my 10 and bring down my 6k squared. Now, then you go, okay, what about this 3? Let's bring down this 3. I can put it back in the mix. 3 times 6k squared is going to give me 18k squared. 3 times 7 is going to give me positive 21k. And 3 times 10 is going to give me negative 30. And notice that's the same thing we started out with. So we know it's correct. Our final answer is right here. So I'm going to put a little arrow, a little line. That's my answer right there. So 3 times 6k minus 5 times k plus 2.